Hello, this is the third video of the Unit 2 Different Technologies, and we are going to see a PT-CSP plant that is parabolic through concentrated solar thermal power plant with thermal storage. The main problem facing weather-dependent technologies is the difficulty to provide energy when needed, because generation is produced when exceeds the required factor. For example, for a wind farm, we need wind, and for example, for a solar thermal power plant and photovoltaic systems, we need irradiance in that moment. So we must take into account that electrical energy cannot be stored. So this hypothesis requires that electricity consumption and power generation must match in that moment. However, it's very important to take into account that electricity cannot be stored, because you cannot stop an electron which is moving around, for example, in a wire. So although this electrical energy has the virtue of being easy to be transported and transformed into other energies, for example, thermal energy or mechanical energy, we are not able to store it. In fact, we must take into account that the electricity we are spending at home is being generated at this moment for example, in a solar thermal power plant. So the electrical system is based on the capacity of generation according to expected punctual demand. So the power plant must match with the energy demanded by the population. It's very important to understand that batteries don't store electrical energy, but they store chemical energy. So they are going to convert this chemical energy into electrical energy. Finally, we need to elaborate a load forecasting. This is a technique used by energy providing companies to predict the energy required by the population and the energy produced by the solar thermal power plant, because both energy must match. Finally, we are going to study other methods to store this energy. At the beginning, we need to understand that electrical energy cannot be stored, because, for example, the piles and the batteries just store chemical energy, and they transform this chemical energy into electrical energy. On the other hand, we have, for example, mechanical energy, for example, springs, because, for example, in a car, we compress a spring and it is going to have mechanical work, and we can transfer this mechanical work into other types of energy, for example, thermal energy or electrical energy. Another type is potential energy. Potential energy is based on the position of an object. For example, in a reversible hydroelectric plant, we have water in the upper reservoir and water in the lower reservoir. When energy is required, the water goes from the upper reservoir to the lower reservoir. And on the other hand, when we have enough energy, for example, at night, because people are not consuming this energy, we can return this water from the lower reservoir to the upper reservoir. And finally, we are going to consider thermal energy. Thermal energy can be stored in liquid air, liquid nitrogen, or in our case, in molten inorganic salts. Here we can see the springs, which are able to store mechanical energy. Here the reversible hydroelectric plant. Here liquid nitrogen. This is the tank. And here molten inorganic salts. Now we are going to speak about the storage possibilities of energy in a solar thermal power plant. In this unit, we are gonna see that the main method is the sensible heat in inorganic molten salts. However, throughout the years have been four main methods, although the first two methods are not used right now. The first method is the sensible heat in the HTF. However, we must understand what is sensible heat. Sensible heat is the heat exchanged by a body or thermodynamic system which modifies the temperature of this body, but is not going to change the other macroscopic variables, for example the pressure or the volume. Imagine that you have a liter of water and you increase the temperature of this liter until 100 Celsius degrees. Is not going to change its state from liquid state to steam state, but the temperature is going to increase. This is sensible heat. On the other hand, we have latent heat. Latent heat is the heat exchanged in a chain of state process, for example from liquid state to steam state. However, the sensible heat in HTF, this method is not used right now nowadays because HTF at high temperatures is flammable and is much more expensive than inorganic molten salts. Now we have storage in the form of sensible heat in concrete. However, this method is not used right now because the efficiency is very low. A hot fluid transfer the heat inside the concrete, and the heat is stored inside the concrete. When this heat is required, a cold fluid is going to be driven through the concrete and is going to absorb this heat. On the other hand, we have the third method and the fourth method, which are very improved these years, although right now they are not mature techniques. This is the storage in the form of latent heat of inorganic molten salts. This is the same, but instead of sensible heat is latent heat, because these inorganic salts are in static, so no pumps are required, and these salts are in liquid states. So when latent heat is required, the heat is transferred to HTF or other systems, and the salts are gonna lose this heat and they are going to solidify. And finally, we have the storage in the form of inorganic salts, but only in one tank instead of two tanks, which is the most mature of this technique. And this is these salts, cold salts and hot salts, are separate by density difference. And this system has a great feature, but right now is not very improved. Now we have that the most mature technique is the store in the form of sensible heat of inorganic molten salts, but with two tanks. The main elements of this process is the following: molten salts, which is a mixture of sodium nitrate and potassium nitrate, and the percentage are 40 and 60. Two steel tanks which are going to store these salts. They have standard dimensions of 40 of diameter and 16 of height, and the standard capacity is 20,000 cubic meters, although the useful capacity is 16 cubic meters. Long VS vertical pumps, which are going to drive these salts from the cold tank to the hot tank. Cell tubes heat exchangers, which are gonna receive this heat, and at the final of this process is going to send this heat to other fluid. And finally, a drainage system, which is very, very useful, because it's very important to ensure that these salts are not in the pipes when the process is not running, because we have to avoid jams in the pipes. Finally, we must understand the thermal storage system operation. We are going to have two tanks, the cold salts tank and the hot salts tank. First, we have the salts in the cold tank, and these salts are going to be driven to the hot tank. The cold tank initially is a temperature of 230 to 280 Celsius degrees, and finally the hot tank will be at a temperature of more or less 400 Celsius degrees. These salts are driven by some vertical pumps, and the HTF transfer its heat to cold tanks. So this HTF loses some heat and the salts gain some heat. So we must understand that this thermal storage is the increasement of the heat of these cold tanks. Then they are stored in the hot tanks, and when we require this heat, we are gonna make the reverse process, because these salts are gonna be driven from the hot tank to this cold tank, and other fluid, for example water, are gonna absorb this heat thanks to the heat exchangers. Here, for example, we can see some examples of vertical pumps. Here I have inserted a video of the vertical pumps animation, how this system works. Finally, you have successfully finished the thermal storage system unit.